Bismillahirrahmanirrahim. I'm Khadr Chuktai and you are watching my YouTube channel, Khadr Chuktai School of Advanced Chemistry. Today I'm going to explain the typical past paper question regarding acid, base and salt for O-level chemistry that is having 5070 code. Let's get started. First of all, I would like to introduce the basic syllabus line regarding O-level chemistry. Let's see over here. The properties, the characteristic properties of the acid and bases. I mean, you know about this one that describe the meaning of the term acid. What is an acid? What is an alkali? In terms of ions, they contain or produce an aqueous solution and their effect on universal indicator paper. So what is an acid? You know, any species, any substance that has ability to lose H positive ion into the aqueous medium, and reversibly you can say a substance that has ability to lose, to generate, to make OH negative ion into the aqueous medium is said to be an alkali. So these are the two typical definitions you can say, and you must know about it, and with examples you can say. Example of the acid, it may be HCl, HBr, HI, I mean hydride of the group 7 elements. And second one is a non-metallic oxide. For example, the typical ones are SO2, NO2, P2O4 and so on. The third category of the acid is organic acid like vinegar. Compound, those are having COOH. COOH bonds in them are said to be the acid, said to be the carboxylic acid. So these three different and the typical categories are over here for the acids, just to choose the example of an acid. The second one is test hydrogen ion concentration and hence relative acidity using once again indicator paper or the pH scale or universal indicator and so on. The next one is excuse me, the properties of the acids. The properties of the acid in reaction with metals, with the base and the carbonate. So reaction with the metal of an acid, acid plus base reaction, acid plus carbonate reaction, these are the typical reactions they can ask from their papers. Okay. Just hold on please. Okay. The next one is describe the neutralization reaction between H positive ion and OH negative ion. I mean, it's a typical acid-alkali neutralization reaction in which H positive ion and OH negative ion react together to make H2O. This is said to be the ionic equation. Whenever any sort of acid, any sort of alkali, not a base, alkali, they are mutually reacting together to neutralizing themselves to make water. This equation is said to be ionic equation of acid-alkali neutralization. Just keep in your mind. Describe the importance of the controlling pH, how the excess acidity is treated with calcium hydroxide and so on. The next one is describe the properties of the base with acid, ammonium, salt. It's a typical one, by the way. Ammonium, reaction of base with ammonium, salt, and reaction of base with the acids and so on. Classify the oxide, acidic oxide, basic oxide, and amphoteric oxide. Acidic oxide, as I told you, the non-metallic oxide, hydride of the group 7 elements, and COOH compound. Compounds having COOH group are said to be the acidic ones and so on. The next one is basic oxides. Mostly metal oxides like Na2O are said to be the metal oxide. Mostly metal oxide are said to be the basic oxide. The next one is amphoteric. These are the three one as far as your level is concerned. Zinc oxide, Al2O3, aluminium oxide, and lead oxide. So three oxides are said to be the amphoteric oxide and so on. So next one is the salt preparation, and you will have to remember this one. Excuse me. Okay. Salt, I mean the preparation of the salt, separation, purification. For example, some technique are already given in your section 1.2 in first, I think, in chapter number 1. The next one is describe the general rule of solubility. I think you are familiar with the general rule. I mean, all nitrates are soluble. All halides are soluble except silver and lead as far as your O-level syllabus is concerned. All sulfates are soluble except barium sulfate, lead sulfate and calcium sulfate. All bicarbonate are water soluble. All compounds having NH4 positive ions are soluble. All compounds having sodium positive, group 1 positive ion, they all are said to be the soluble. The next one, insoluble, mean all carbonates are insoluble except sodium and ammonium ions. Salt. Almost oxides are insoluble. All oxides, all hydroxide are insoluble except group 1 and 3 group 2 members. Those are lying at the bottom of the group. 3 group members of group 2 and almost all group members of group 1 except lithium, their oxides are soluble. Oxide of group 1 is soluble except lithium. Oxide of the group 2 are soluble below the calcium, and rest of all metal oxide and rest of all metal hydroxide are water insoluble. They are not water soluble and so on. The next one is how to prepare. One is the precipitation method that is used to make an insoluble salt, and the titration method that is used to make a soluble salt. Typically, there are 5 methods basically, but the typical one is the titration method that is frequently asked in the past paper history. The next one are the rules of solubility of the nitrates, chlorides, as I have told you, and so on. These are the typical points that you have to remember, you have to revise, and so on. The next one is the properties and uses of the ammonia. Synthesis of ammonia, nitrogen from air, hydrogen from the cracking of the hydrocarbons. They are meeting together, they are kept together in a sealed container. There is a reversible reaction, and ultimately, under certain condition, in the presence of iron catalyst, in the presence of 450 degrees Celsius, that is an optimum temperature, and under, you can say, 200 to 300 atmospheric pressure, there is the formation of ammonia. The further one is the uses of ammonia and so on, and the problem regarding the nitrogen, that is eutrophication, and why we cannot use the salt, ammonium salt, in coordination with the calcium hydroxide. There is a typical reaction, as I told you in my previous page, that calcium hydroxide or any sort of base react with ammonium salt. All ammonium salt, keep in your mind, all ammonium salt are going to behave as an acidic salt. These are said to be the acidic salt. So they happily react with the calcium, ammonium, and any other hydroxide, calcium hydroxide, not ammonium, calcium oxide, sodium hydroxide, any sort of base, you can say, especially hydroxide and oxide. And there is formation of ammonia gas as a reaction. One substance that is formed is ammonia. Second one is H2O. The third compound is formed that is said to be the salt. So whenever ammonium salt, any sort of ammonium salt, ammonium nitrate, ammonium sulfate, ammonium phosphate, any sort of ammonium salt, ammonium chloride, you can say, when it is allowed to react with any sort of base, with any sort of alkali, you can say, like calcium hydroxide, like sodium hydroxide, and so on, like magnesium hydroxide, even if it is heated with the MgO or calcium hydroxide, especially, you can say that, then there is the formation of ammonia gas. Water is being formed in this case, and a salt is formed. Salt is formed, the metal from this base and non-metal from this one. It may have CaCl2 in case of calcium hydroxide. It may be CaNO3 in case of ammonium nitrate, CaSO4 in case of ammonium sulfate, and so on. So this is one of the asked the question in the past paper history, and you must know about it. The next one is sulfuric acid. Describe the manufacturing of the sulfuric acid, the raw material of the sulfuric acid, that is sulfur, air, and water. These 3 are the basic ingredients. Those are used to synthesize basically the sulfuric acid, and that is said to be the contact process. In this case, once again, the use of the sulfur dioxide, that is as a bleach, and it is used to bleach the wood pulp for the production of the paper, food preservative that is used to kill the bacteria, and so on. The next one is, you can say, the uses of the sulfuric acid in detergent, in making a fertilizer, and battery acid or battery electrolyte, you can say, that is the basic use or the basic uses of sulfuric acid. Now come towards the next one, that is the salt preparation. As I told you, there are two types of salt. One is said to be insoluble salt, and other ones are said to be soluble salt. Insoluble salt are made by the simple method. I mean, there are almost 3 to 4 steps sentence you can write. Insoluble salt are formed from the two aqueous compounds, two aqueous soluble salt. For example, I'm supposed to make AgCl, then I will mix AgNO3. It's a soluble. I'm going to write aqueous over here. That is a demonstration. That is indication of its solubility. And the next one is NaCl. That is, again, you must remember about the solubility table, and all type of solubility that is included in your syllabi. And finally, we are going to make a solid salt. The combination of two aqueous solutions, if they are going to bond, if they are going to make an insoluble compound, it is said to be the precipitate. It is said to be precipitate, and even though there is another species that will be definitely the soluble, water soluble, in this case that is sodium nitrate. So you will mix two solutions, two soluble solution. Finally, they are going to bond an insoluble solid, that is said to be the precipitate. Then after that, you will shake them properly to ensure the completion of the reaction. Then you will filter it out. The next one is wash and dry the residue, the precipitate or salt, you can say. These are the typical you can say the points that you have to remember. The next one is how to make soluble salt. There are basically 5 methods. The typical method is over here. When you are using soluble base, like if you are using Na2O, if you are using NaOH, and same is the case if you are using KOH or K2O and so on. So these are said to be the soluble base. Whenever you are going to use, it's up to you, or it's up to the question, the statement of the question, the demand of the question. If you are using soluble base, then you will have to write all these options to secure at least 4 to 5 marks. Number 1, you will choose the proper acid and proper base. Then you will mix them via titration method. Then you will repeat the same titration without using the indicator, and then the mixture is heated to make it concentrated solution, to make it saturated solution, and so on. After saturation, this mixture is then cooled, and it is left to stand for, you can say, for the formation of the crystals. When crystals are formed, they are filtered, and you can collect the crystals, wash with the cold water, and minimum amount of cold water is used in this scenario. Wash with the cold water and dry the crystals. That is the last one. So if you are using acid plus a soluble base, then simply it means you will use this method, the typical points you have to remember, you have to report into your paper. That is their one. The next one is, if you are using insoluble base, examiner is asking, there is compulsion to use insoluble base like iron hydroxide, then you will use this base in excess. You will use excess soluble base. That is the main point of to report, to write your answer, you can say. So you will mix HCl plus iron, let's suppose iron hydroxide, and you will mix them, but this quantity of the insoluble base will be in excess. Then you will stir, heat, and filter the solution. You will discard the residue, that is excess one. Again, you will heat, these are the common one. You will heat the filtrate to make it soapy solution, to make a concentrated solution. Cool the solution, or the filtrate, you can say. Filter the solution when the crystals are appeared. I mean, you have to collect the crystals, wash them with the cold water and dry the crystals. So these are the typical points. They are very much essential to report the accurate and appropriate answer. Now let's see how to solve the different past paper question. This question is from November 21. The structure of the angelic acid is shown that is said to be the organic acid. As you can see over here, this is COOH group, so it's an organic acid. Explain how this structure show the angelic acid is an unsaturated compound that is belonging to the organic compound. By the way, if a compound is having carbon-carbon double bond, if the compound is having not because of this double bond, because of CC double bond, because of carbon-carbon double bond, it is said to be unsaturated. Because of CC double bond, it is said to be unsaturated, and so on. Deduce the molecular formula of angelic acid. Once again, that's not the part of acid-base reaction. However, it's a part of the examination. Count the carbons. First of all, 1, 2, 3, 4, and 5, if I'm not wrong. 1, 2, 3, 4, 5, write C5. Then count the hydrogens, and 1, 2, 3, 4, 5 plus 3, 8, and 2 oxygens are there. So its molecular formula C5H8O2, if I am not wrong. 3 plus 3 plus 2, yes, I think I am right in this respect, and yes, answer is the formula. Angelic acid is a weak acid. Define term acid. Once again, as I told you, this is a typical question. Any substance that releases H positive ion in aqueous medium is said to be an acid. Explain the term meaning weak as applied to the acid. If acid is partially soluble in water, then it is said to be the weak acid. It is going to lose less number of H positive ion, less quantity or less number of H positive ion into the aqueous medium, then it is said to be the weak acid, and so on. The next one is the next question. This question is about ammonia and nitrate. State the source of hydrogen and nitrogen used in the manufacturing of ammonia by the Haber process. As I told you, few minutes ago, the source of hydrogen is the cracking of hydrocarbon. And nitrogen source is air, fraction distillation of the air. Fractional distillation of air, and so on. Ammonia is formed when aqueous ammonium sulfate is heated with sodium hydroxide. A student add that belongs to the stoichiometry. Once again, let me see, and let's do it. Student adds 5.4 gram of sodium hydroxide to 50 centimeter cube of 1.25 mole per dm cube aqueous ammonium sulfate. Show by calculation the ammonium sulfate is in excess. Simply speaking, first of all, as I told you in my previous lectures, that these two information gives us the number of mole of that species, that is ammonium sulfate. So moles of NH4 twice SO4, that is ammonium sulfate, that is equal to 50 into 1.25 divided by 1000. What is the answer of the mole of? Please help me out to find this answer. Let's see, 50 into 1.25 divided by 1000, and here is the answer, that is 0.0625. 0.0625 are the moles of NH4SO4, NH4 twice SO4. Now the next one, what are the mole of sodium hydroxide? I'm going to find the mole of sodium hydroxide. Moles of NaOH. 4.50 divided by its MR is equal to 40. And what is its answer? 4.5 divided by 40, and moles are equal to 0.1125. It's a mole of NaOH. So according to the chemical equation, 1 mole of this ammonium sulfate demanding required 2 mole of NaOH, right? Its 1 mole is going to demand, its 1 mole is demanding for the complete reaction, that is the double mole of sodium hydroxide. What is the double mole of sodium hydroxide? You can say that I'm going to multiply 0.0625 into 2. The answer is 0.125. 0.125. So the demand of ammonium sulfate is 0.125, but the available NaOH is equal to 0.0125. So NH4 twice SO4 is in excess. There is another shortcut to find the limiting reactant and excess one. That is this one. I'm going to write with a different pen. We have find the number of mole of NaOH, that is equal to 0.1125. We have find the number of moles of this one. Let me change my pen's cursor, or you can say the width, you can say. And in this case, you can see that the number of mole are equal to 0.0625. So I'm going to divide the number of mole of original moles from the balanced chemical equation. I'm dividing by 1 to the mole of ammonium sulfate. I'm dividing by 2 to the mole of sodium hydroxide. So find the number of moles first, then divide the moles from the balanced chemical equation. Now let's see, it's having the same answer, 0.0625. What should be its answer? Its answer will be 0.1125 divided by 2, and its answer is 0.056. Its answer is 0.056. Which one is the lower one? That is this one. So it is limiting reactant. It's a limiting reactant. And which is the higher? That is said to be excess. So these are the two basic methods to find the limiting reactant and to find the excess reactant and so on. Now come towards the next one. Methanoic acid and ethanoic acid are the weak acids. What does mean the term weak acid? Apply to the acid, as I told you, that partially ionized to give H positive ion into the aqueous medium, or less number of H positive ion are being lost by that substance, you can say, by that molecule, is said to be the weak acid. Methanoic acid react with magnesium powder. Construct the chemical equation for this reaction. So to construct the chemical equation, it is more wise to write its molecular formula. 1CH2O2. I am going to react it with magnesium powder, Mg. What is the result of this reaction? First of all, I'm on the rough page, you can see that this is the acid, you can say, that is methanoic acid. Only this hydrogen can be replaced. Whenever this acid is going to react, it will make this negative ion. And when magnesium is allowed to react, it will lose its 2 positive ion because it belongs to the group 2 elements. So combination of these two, this negative ion, this positive ion will be, I'm going to write it over here. Magnesium 2 positive ion, it is having 1 negative ion. So 2 positive and negative will be cancelled out. 2 will be over here and 1 will be over here. So exact formula of this salt will be MgHCl OO twice, right? So I'm going to write it over here, Mg, that is HCOO twice plus H2. Whenever acid react with a metal, there is the formation of H2 gas. Whenever an alcohol react with the metal, again there is the formation of H2 gas and salt. Whenever water, if water is going to react with the metal, or if the metal is going to react with the water, then again H2 is formed. H2 gas is formed in 3 different scenarios: when metal is going to react with acid, when metal is going to react with alcohol, when metal is going to react with water. Just keep in your mind. The next one is state and explain how the rate of reaction changes when experiment is repeated using the piece of magnesium ribbon with the same mass as powder. Now this time he is going to use magnesium ribbon. Initially it was using the powder. In case of ribbon, all the other conditions are same, and about the collision of particle, and so on. In case of magnesium ribbon, it has low surface area. To react with acid, or you can say collide with acid particles or acid molecules. So less number of effective collision per unit time. That is a common sentence in all sort of the reasoning of the rate of reaction. Less number of effective collisions per unit time, or the frequency of effective collision will be less. That is a typical one. Number 1, low surface area, that's 1 marks. And the second one is less number of effective collision, that is for the second mark. Methanoic acid react with the propanol to form an ester. Draw the structure of the ester. And once again, you can say the organic acid are having this special property. This is a special property of the organic acid. It cannot be exhibited by the normal mineral acids. This reaction cannot be carried out with the help of HCl, with help of by the H2SO4, by phosphoric acid, and so on. So this is the special property of the acid that is said to be the carboxylic acids. And methanoic acid is going to react with the propanol. I am going to write its structure and all the things. First of all, on the rough page, you can draw the structure of methanoic acid. This is the structure of methanoic acid and the structure of the propanol. And I'm going to write OH on the side of acid, CH2, CH2, and CH3. That is the full formula, or you can say the basic structure formula of our condensed formula of the propanol. So when they react together for the esterification, there is a loss of OH group from acid, even though it is an acid, but it will lose OH group. And this one, alcohol will lose hydrogen atom and so on. So as a result, you will get this one structure, HCOO, CH2, CH2, and CH3. The name of this ester is, you will write the name first, that is from alcoholic part. Its name is written as, at the first part of the name, and second part of the name is written on from the side of the molecule. There is only one carbon, so its name will be methanoate. Methane, E, just remove E, OATE, methanoate. What is the name of this one? It's a 3 carbon group. Its ending name will be YL. It will be prop, and removing in, we will write YL. Propyl methanoate. So name is propyl methane. Don't write EOATE. So it's a name, propyl methanoate. The next one is ethanoic acid is present in the vinegar. Name the organic compound which is converted to ethanoic acid when vinegar is made. Once again, this is a typical question that is from the synthesis of ethanoic acid. You know ethanol. ethanol. Alcohols are converted, are oxidized into the carboxylic acid. Alcohols, and they are said to be the primary alcohol. Only one, I think, only 4 alcohols are in your syllabus. Those can be oxidized. I mean, methanoic acid, methanol, ethanol will change into ethanoic acid, methanol will change into methanoic acid, propanol will change into propanoic acid, and butanol will change into butanoic acid. Just keep in your mind. Name the organic compound which convert ethanoic acid. All acids are synthesized from organic compound. As far as O-level chemistry is concerned, they are going to made from alcohols. So ethanoic acid mean it is going to form ethanol. First name will be the same. Ethanol, the compound that is converted into the ethanoic acid. What type of chemical reaction is this? As I told you, it's an oxidation. Oxidation. And if he is asking to write the conditions, then the conditions are, if he is asking K2Cr2O7, or you can write KMnO4, and acid should be there. And the third one, there must be the heat as well. Heat under reflux. These are the conditions they may ask. The next one is, table shows some properties of the 4-carboxylic acid. Predict the density of the ethanoic acid. This is the production. You can say density is going to decrease. What is the difference between these two? That is 0.03, I think. So I'm going to write the similar pattern. 1.22 minus 0.03. What will be the answer if I'm not wrong? 1.22 minus 0.03. Yes, 0.03. And its answer is 1.19. So it may be 1.19 and so on. Describe and explain the change in the boiling point as the number of carbon atom in a molecule increases. Definitely, if the carbon atoms are going to increase, its boiling point will increase. Its boiling point will increase with increase in carbon atoms. Because more carbon atoms, sorry for that, there is no extra space, more carbon atoms in a molecule, stronger the intermolecular forces. Stronger the intermolecular forces. More the carbon atom, more the stronger the intermolecular forces in that compound. And so on. Come towards the next one. Butanoic acid, that is again, unfortunately, a carboxylic acid. Draw the structure of the butanoic acid to show all the atom and all the bonds. Once again, this is the group that is said to be the acidic group, carboxylic acid, and rest of all 3 carbons and 7 hydrogens are there. 3 carbons, and each carbon valency must be fully satisfied. So I'm going to distribute the hydrogens over here, and this is the displayed formula of butanoic acid. Describe the movement and arrangement of the particle in the liquid butanoic acid. Moving mean random movement or freely moving, you can say. Arrangement is irregular. So irregular arrangement and random movement, you can say roughly that is the true one. The melting point of the butanoic acid is -4. The boiling point of the butanoic acid is 166 degrees Celsius. Deduce the physical state of the butanoic acid at 0 degrees centigrade. I mean, it says 0 degrees centigrade. I'm going to mark a line now. You can say, you can draw Haizer scale, my own scale, if you are familiar with my book. 0 degrees Celsius and you are going to increase this. Let's suppose the 1 degree Celsius and here is the minus 1 degree Celsius. So what about its boiling point? Its boiling point is over here. Its boiling point is 166. Sorry, 166. Its boiling point is higher, but its melting point is lower. That is at minus, you can say minus 4. So, if the melting point is lower than that of a specific temperature, then it's a liquid, and its boiling point is higher. Once again, this is also mean it's a liquid. So, boiling point is higher, melting point is lower than the specific temperature. So, its physical state must be in the liquid state. And same is the answer over here. Boiling point is higher than 0 degrees centigrade. And the next one is melting point is lower than degrees Celsius. You will write in the complete sentence, in the proper sentence, and so on. Equation for the reaction of butanoic acid with sodium carbonate is shown. A student add 5.2 gram of butanoic acid to 50 centimeter cube of 0.5 mole per dm cube of sodium carbonate. By calculation, you will have to prove that butanoic acid is in excess. I have told you, I'm not going to solve it again. Come to the next one. Magnesium react with the butanoic acid, the product of the magnesium, butanoate and hydrogen. Once again, he is asking to write the reaction magnesium plus butanoic acid. It is more wise to write its formula. C3H7COOH. I'm going to report it over here. C3H7COOH goes to, there is the form of hydrogen gas, as he told you, and the next one is salt. It's having 1 negative ion, it's having 2 positive ion. So magnesium, small bracket, CHCOO, 1 negative twice, that is the name, formula of the salt. Magnesium, that is butanoate. One method of determining the pH of the aqueous butanoic acid is using the pH meter. Describe a different method to determine the pH of the aqueous butanoic acid. Whenever they are asking to find the alternative method as compared to the pH the meter, that is appropriate one is universal indicator. Universal indicator. You will use universal indicator. Its color and its pH scale, you can say, will let you know the exact pH. Exact pH of solution. Its colors, when you will introduce, first of all, you will introduce the or use the universal indicator. The color change or the color obtained as a result of reaction with the acid, then you will match it from the pH strip or the pH scale, the color scale, you can say, and it will let you know the exact pH of that solution. So universal indicator has two advantages. Number one, it will indicate either the solution is acid or neutral or alkali. The second one, it will also give you the strength of acid and alkali. If it is a stronger acid, it will you can check it the exact pH. It will be the lower one. If it is a stronger alkali, then its pH will be the higher one, almost around 12, 13 and 14 and so on. So universal indicator is the appropriate indicator to check the nature of the liquid, if it is an acid or alkali. The second one, it is going to announce you the strength of that acid and alkali and so on. Now come to the next one. Sulfuric acid is made by the contact process. Name the catalyst used in the contact process. That is said to be vanadium oxide. Vanadium 5 oxide. Describe how and explain why position of equilibrium in the reaction is altered when temperature of the equilibrium mixture is increased. That is again one from the, you can say, the rate of reaction question. When the pressure is increased, equilibrium will shift towards that side where there are less number of moles. So equilibrium will shift, because if the number of mole of the gases especially are different on the both side, and on increasing the pressure, equilibrium will shift towards where there are less number of mole, and hence that is said to be the change in or the shifting of equilibrium. The next one is at constant, the pressure of the equilibrium mixture is increased. Temperature of, sorry, the first one was temperature increased at constant pressure, not the pressure one. If the temperature is going to increase, then see what is the nature of this reaction, that is exothermic one. So increase in temperature will, reverse the reaction, will boost the backward reaction. So increasing temperature will favor the reverse reaction, and equilibrium will shift towards backward side. So equilibrium will shift towards left hand side because reaction is exothermic. Forward exothermic reaction is not favored by increasing the temperature. Basically, increase in temperature is favored, or that favors the endothermic reaction. If the forward reaction is exo, then obviously the backward reaction will be endo. If the forward reaction is exo, then the backward will be endo, and so on. And rest of the next one is, once again, if you are going to increase the pressure, equilibrium will shift towards that side where there are less number of moles of the gases. There must be the different number of mole of the gases, or even one gas may be present, but there should be the presence of the gas. So equilibrium will shift towards that side where there are less number of moles, and it may go to increase the yield, it may go to decrease the yield, and so on. In this case, you can see that there are 3 moles on the right hand side, 2 moles on the left hand side. So increase in pressure will shift the equilibrium towards the right hand side. In this case, equilibrium will shift towards right hand side from more moles to less moles, and so on. The next one is final step, manufacturing of this one, and he is saying to write the diagram, the reaction and the products, enthalpy change of the reaction, activation of energy, and so on. This is an, you can say, exothermic reaction. So I'm going to draw the 2 basic lines to energy state for reactant, and here is the product. Reactant must be at high energy level in the exothermic reaction, and the product should be at low energy level. And here is, you can say, a peak, a normal peak, you can say. From reactant to this peak, this height is said to be energy of activation, and from reactant to the product, these both arrows are originating from the reactant line, and it is said to be the delta H, and so on. Air is the raw material used in the manufacturing of sulfuric acid. Name other raw material used in the manufacturing of sulfuric acid. As I told you, the next one is sulfur and water. State one major use of sulfuric acid for battery acid. You can say it is used to make the fertilizer, and so on. There are 3 to 4 uses basically. Acids are neutralized by the alkalis. Write the ionic equation for the reaction between acid and alkali. Ionic equation is a similar one that I explained in my first slides. That is equal to H positive ion aqueous plus OH negative ion aqueous goes to H2O liquid. So that is the aqueous over here. That is the common answer for all type of acid alkali neutralization reaction. Just keep in your mind. Sodium sulfate is a soluble salt that can be prepared by the titration method. Name a compound and the acid that can be used to make sodium sulfate by this method. Name a sodium compound and acid. It's a soluble salt, you can say. Soluble salt may be synthesized from the 5 different methods, and in this case he is asking the titration method. In titration method, both compounds must be water soluble. So one is the, you can say the acid one, that is sulfuric acid, H2SO4, and what should be the salt of the base of the sodium? Obviously he is asking the name, to write then write the name, sodium hydroxide. So it must be an alkali, it must be a water-soluble compound. Describe the titration method which is used to prepare a colorless solution of the sodium sulfate. Now the titration method, for titration method basically there are three major equipments those are required. Number one, that is the pipette. Number second, that is the burette and flask. So pipette and burette and flask, these are the basic ingredients, you can say that. Then simply it's a 3-mark question and you will write the basically this one here is the appropriate answer. You can say place alkali in a flask. You can reverse it. Alkali over here and fill burette with the acid. Then add few drop of indicator. An appropriate indicator. This alkali is filled by this pipette. I mean, if you are going to measure 25 fixed volume, 25 centimeter cube, then you will use the one and only equipment that is said to be the pipette, and so on. So first of all, place alkali in flask, you can say, and acid in burette. With the indicator, you can say that. Plus indicator, add indicator. Indicator, it must be the appropriate or suitable indicator. A suitable indicator. Then you will mix them until the end point. Mix till the end point is over here. Color change of indicator is visible. End point till the color change of indicator. Then you will repeat this whole experiment without indicator. Repeat whole experiment without indicator. And so on. That is enough for the 3 marks questions. Describe how the sample of the pure sodium crystals can be made from aqueous solution. Now, this is the question from the chapter number 1. This is said to be the process of crystallization. If you are going to synthesize or make or retrieving a solid from the solution, then there are you can say 3 to 4 points and so on. Here they are. Heat the mixture, first of all, to make it soupy, to make it concentrated and so on. Then cool that solution to make the crystals. Filter the solution and collect the crystals. Wash with the cold water and dry the crystal. These are the enough points. This is the complete whole procedure. Even question is of 4 marks and so on. The next one is, once again, he is asking to find barium sulfate, that is an insoluble salt. You are going to make another salt, that is the barium sulfate. Once again, you will have to choose the 2 solutions. Those must be the aqueous one. I am going to divide this compound into 2 parts. The compound of the barium and compound of the SO4 negative ion should be there, and they both must be water soluble. You can use H2SO4. You may use Na2SO4, the soluble compound of the sulfate. And similarly for barium, you may use barium nitrate. So these are the 2 appropriate compounds. Those can be used to synthesize barium sulfate. 2 aqueous solution. One is the barium nitrate, aqueous, plus the second one is, let's suppose, Na2SO4 aqueous, and we are going to mix them and we will shake them and then we will filter. As a result, you can say there is the solid barium sulfate. It is insoluble salt, and rest of the compound will have a soluble compound in the water, that is sodium nitrate. I think 2 mole of NO3 aqueous. So it's a solid, it's insoluble, it's a precipitate, and it will be filtered and it is then washed, then the residue is collected. So first of all, mix 2 solutions, write the name of 2 appropriate solutions, and in this case he is also giving us the barium chloride and dilute sulfuric acid. Even though if the options are not given, you should be able to constitute to choose the appropriate one. Then you will mix them. There is the formation of precipitate. Mix them and it will lead to the precipitation. A solid will form, right? and then you will filter this solid, and then you will wash and dry, and so on. Write the ionic equation including state symbol of this reaction. Ionic equation for this one is basically, I'm going to write in reverse way. It's a barium sulfate solid. No need to write the aqueous one. Just write that insoluble solid. Just. So it's a solid. It is going to make from two ions. One is the barium ion, second one is the sulfate ion. So I'm going to write the barium ion. It's 2 positive aqueous ion plus which one is the negative ion is SO4 negative ion. It is having 2 negative ion and it's aqueous. Equation is balanced. State symbols are over here. Barium 2 positive ion are going to react with SO4 2 negative ion to make barium sulfate. This is the easiest method to write precipitation reaction. This is the easiest method to write ionic equation for the precipitation only. If you are asked to write the precipitation reaction or the ionic equation for that reaction, then this is the easier one. Right? First of all, you will write the product, then you can change, you can assess which positive and which negative ions are going to meet together to make that, sort of compound and so on. The next one is nitrogen dioxide react with water to make HNO3 and nitrous acid HNO2. Construct an equation for this reaction. That's very easy. NO2 is going to react with H2O to make two sort of acid, HNO3 and HNO2. So it means that at least number of nitrogen must be 2 over here. I'm going to balance it. So 2 nitrogens are over here on the right hand side and 2 are on the left hand side. How many hydrogens are here? 2 hydrogens, 1 is over here, 1 plus 1, 2, and here are 2. Hydrogens are also balanced. 2 2s are 4 plus 1, 5 oxygens are there and 5 oxygens are there. It's a balanced one. Nitric acid is a strong acid and nitrous acid is a weak acid. Describe the difference between strong and weak. Once again, that fully ionized to liberate H positive ion, aqueous in high concentration, is said to be the strong acid, and the weak acid that is partly ionized to lose less number of H positive ion in water in aqueous medium, you can say, is said to be the weaker one, is said to be the weak acid, and so on. So here is the next question. Hydrochloric acid react with barium hydroxide. The reaction is over here. A sample of 20 centimeter cube of 0.05 mole per dm cube of the barium hydroxide is used in the beaker. This volume, you can say, and here is the concentration. Dilute HCl added slowly from the burette to the barium hydroxide in the beaker, and here is the whole history of that experiment. Explain in terms of ions present why pH of the solution in the beaker changes from 13 to 0.9. 13 to 0.9. So you can see that from burette you are adding HCl, and in the flask that was the alkali, that is barium hydroxide. So concentration of OH negative ions decreasing as a result of reaction with H positive ion. As a result of reaction with H positive ion. Sorry, I think that is not enough space. H positive ion. And finally, H positive ion in excess, and H positive ion finally is in excess. So pH changes from 13 to 0.9. The next one is use the data table. The volume of dilute acid just neutralize all the sample of barium hydroxide. So in this case, as far as my opinion is concerned, You may use, you can say the uh, table, this one, or you may use a formula as well. If the table is not given, C1 V1 over N1 that is equal to C2 V2 over N2. If the table is not given, then you will be two volumes and at least one concentration, or two concentration and one volume will be there, and rest of the species may be asked. So you can see from this column that is having the pH equal to 7. At 7 pH, what is the volume of acid used? That is equal to 20. So I am going to write 20 over here. So this is the appropriate exact volume of the acid that was used till end point. The next one is, use answer B to calculate the concentration in mole per dm cube of dilute HCl. Wow. So you know the concentration is, the formula is concentration into number of mole into 1000 over V, if the volume in centimeter cube. And he is asking to find the concentration, so we are going to find the C, number of moles of this one, and volume. We are not having mole at the moment, however, we are having the volume that is equal to 20 centimeter cube. I am going backward to see the data of this one. Dilute HCl, it's having total volume 40 centimeter cube. And where is the second one data? You can say that barium hydroxide is 25 centimeter cube. This one, you can find the moles of this one. Volume is over here. And is there any sort of mole of acid? I think there is no mole given in this way. So we will have to calculate the number of moles of the acid from this equation by unitary method. So I am going to calculate it. What is the mole of barium hydroxide in the given experiment? Given experiment, you can say that 25 into 0.05 divided by 1000, and you will get the mole of barium hydroxide, right? That is the overall mole at the moment, you can say, and till the point of neutralization. What is its mole? What is its answer? Please let me know. 25 into 0.05 divided by 1000, and answer is, if I'm not wrong, its answer is 1.25 into 10 raised to power minus 3 moles. From balance equation, you can see that 1 mole of barium hydroxide is equal to 2 mole of this one, that is HCl. So the mole of HCl will be 2 into 1.25 into 10 raised to power minus 3 multiplied by 2, and here is the answer, that is 2.5 into 10 raised to power minus 3. It's 2.5 into 10 raised to power minus 3. So we have calculated the mole of HCl, right? So it is equal to 2.5 into 10 raised to power minus 3 multiplied by 1000 over 20. So I'm going to multiply with 1000 if I'm not wrong, and dividing by 20. The answer is 0.125 mole per dm cube, if I'm not wrong. The next one is, if I'm not wrong in my calculation. The next one is this. This question is about the sum oxide of the element in period 3. State the electronic configuration of the negative ion in sodium oxide. You know what is the negative ion in this oxide? There's oxygen 1, O minus 2. What is the total atomic number of this oxygen? That is equal to 10. So 2,8 is the electronic configuration of oxide ion, 2,8. Magnesium oxide is an insoluble base that can be used to prepare magnesium sulfate crystals. Once again, as I told you, now he is saying that this is an insoluble base, and he is going to use to prepare magnesium sulfate from this base. Describe essential practical detail of the preparation of pure magnesium sulfate crystal from magnesium oxide. Once again, it's an insoluble base, so it will be used in excess with the acid. It will be used excess in the acid, and so on. Its appropriate answer is over here. You can see that Once again, you will take acid in this case, that is equal to H2SO4, and you will take the base, that is magnesium oxide, right? You will write MgO, and you will access the magnesium hydroxide, you will stir, heat and filter, heat to concentrate the filtrate and so on, filter the solution to collect the crystal, cool the solution to make the crystals, and then crystals are collected, wash with the cold water and dry the crystal, because once again this magnesium sulfate is you can say water soluble sulfate. So water soluble compounds are washed, but with a minimum amount of cold water, not with the warm water, not with the normal water, and minimum quantity of water is used for their washing. Finally, you will dry it. That is enough for your 4 marks, and I think you can write now this answer by yourself. The next one is sulfuric acid H2SO4 react with sodium hydroxide NaOH as shown. Sulfuric acid plus 2 mole of NaOH goes to sodium sulfate and H2O. A sample of 20 centimeter cube of 0.05 mole per dm cube H2SO4 is placed in the beaker. NaOH is added slowly from the burette to the sulfuric acid in the beaker. A pH probe is used to measure the pH of the solution. I mean, this sort of the question regarding the pH curve. And until total centimeter cube of NaOH is added. So this is the flask pH. I mean, pH of the flask. Initially is one acid. Gradually it is going to increase, and there is a steeper line that is showing the neutralization. It's showing the neutralization, and this line is going to show the excess of that is sodium hydroxide. Explain in terms of ion present why pH of the solution beaker changes from 1 to 13. Once again, that is a similar one. I mean, H positive ion concentration, aqueous H positive ion concentration is decreasing as a result of neutralization, and finally OH negative ion concentration is higher. Negative ions are in high concentration. So pH changes from 1 to 13. You can write an appropriate sentence by your own way. So the next one is the similar one. Again, he is asking to find the volume of NaOH that was used till the end point. Once again, as I told you, you can see it over here. Then this straight line, when you are going to extrapolate towards x-axis, then this volume is the volume needed till the end point. Once again, this straight line portion is extended towards, extrapolated towards x-axis, and this volume is said to be the volume that was required for the exact neutralization. I mean, this volume was required to equalize the number of mole of H positive ion and moles of OH negative ion. That is said to be the equivalence point. That is said to be, in other words, the end point. So 20 centimeter cube is present, the required for this complete reaction. Again, he is saying to calculate the concentration of the sodium hydroxide. Once again, C is equal to N into 1000 over V, and in this case V is equal to 20. You will have to calculate the number of moles first from the given data that is given on the previous pages. Once again, you will calculate the mole of sulfuric acid first. Then you will double the mole of sulfuric acid. That will be the mole of NaOH. I am going to write it over here. 25 into 0.055 divided by 1000 multiplied by 2 will be the mole of NaOH. In short, you can see that, and I am going to write it over here. 25 multiplied by 0.055 into 2 divided by 1000, if I'm not wrong, 2.75 into 10 raised to the power minus 3. So 2.75 into 10 raised to the power minus 3. C is equal to 2.75 into 10 raised to the power minus 3 multiplied by 1000 divided by 20. So what will be the answer? Multiply by 1000 divided by 20, and here is the answer, that is equal to 0.1375. So 1, 2, and 3, these are the appropriate answers. I mean, the use of this mole is equal to 1 marks, use of volume is equal to second marks, and the accurate formula to find the accurate mark, that is equal to this one. So that's all about today. You may ask any sort of thing, you can see that, and you can revise this one and so on.